Okay, welcome everyone. Thanks for being here. It's a pleasure to have here Professor Agustin Rayo from Massachusetts Institute of Technology. Some of you already know him. For those who don't, Agustin Rayo has worked in many fields, in many areas of analytic philosophy, ranging from truth, metaphysics, vagueness, higher order logic, and the philosophy of math, of course. He has published in almost all most important journals, including News, Analysis, Mind, Philosophical Review, Philosophia Mathematica, Notre Dame Symbolic Logic, Notre Dame Journal of Symbolic Logic, and so on. He has edited, together with Gabriel Supiano, a collection of papers in philosophy of logic, especially in absolute generality, and recently this year has published a book, his first monograph for Oxford University Press, called The Construction of Logical Space, and is going to give here today and tomorrow in Bologna. You're both invited, of course, you're invited to both seminars, of course, talks from themes from the book. And so the title of his talk today is Nominalism, Trivialism, and Logicism. Welcome.
Oh, thank you so much. I'm so happy to be here. I really thank you for the invitation. So, as Andrea said, today's talk comes from the book. It's chapter 3 of the book, but this is what happened. I was in a reading group with Andrea talking about chapter 3. And then after that discussion, I thought, my God, I need to rewrite chapter 3. So the way I put it is maximally confusing. So what I did is I rewrote chapter 3. And this talk is based on a paper called Nominalism, Trivialism, Logicism, which is the rewriting of chapter 3. So another reason to thank Andrea. The talk is divided into 2 parts. Does everybody have a handout, by the way? Okay.
Can you share it? Okay.
Okay. So for those of you that do have a handout, you'll see that on page 1 there is part 1, and then on page 4, part 2 starts. So what I think we might do is focus largely on part 1. So part 1 is setting up a problem, and then part 2 is my crazy solution to the problem. But I think it's better if we go slow and be clear about the problem, and then if there's time and if people are interested, then you can hear about my crazy views. Request I have is that you please interrupt. And I'm going to ask Francesca and Andrea to set the example by interrupting often, so that people take seriously the idea that you really ought to interrupt. Also, I often struggle when people give talks in other languages, so like if you want me to speak more slowly or louder or in Spanish.
I asked for some more abstracts.
So a perfectly good interruption is like, I just didn't understand what you said, that I will just try to repeat it. So please don't be bashful. Okay, so let me start by telling you what the problem is. So there is this view in the philosophy of mathematics, which tends to be called nominalism. And according to nominalism, there are no numbers. And more generally, mathematical objects don't exist. And people often like nominalism because they think that one gets a more elegant picture of the world. So to use a phrase of Quine's, if one has a taste for desert landscapes, that's the kind of picture of the world one might like. Another reason people tend to like nominalism is because they think that mathematical epistemology is easier. So if one wants to, if one thinks that numbers exist and thinks that they live in this separate world of abstract objects, so I think this is a bad picture, by the way, but this is what some people think. That like over here you have this looks like maybe I shouldn't use it here. Oh no. So over here you have things like tables and chairs and volcanoes, and then there's this separate realm where you have things like numbers and mathematical objects. And then people say, well, but look, the only things that we interact with causally are things in here. We have no causal access to things over there. So it's deeply mysterious how we could ever know anything about what goes on in this realm of abstract objects. So one reason some people like nominalism is because they say we get a picture of the world without that. And therefore, there's no mystery about how one can know things about the things that do exist. There's no mystery about how we can know things about the world. Okay, so that's the view. And the problem with the view is that if there really are no numbers, then one would think that many sentences that we think are true are in fact false. So for example, we tend to think that that sentence is true, but one might have thought, I mean maybe that's not so, but one might have thought that in order for this sentence to be true, the number 2 has to exist and the number 4 has to exist. So a problem if you're a nominalist is to explain what the point of using sentences like this would be if it turns out that they're all false. The main way in which nominalists try to address the problem is what I suspect that this is no accident. There's a slight tip in the tip. May I throw this away so that it never happens again?
It doesn't work. Not if it's new.
Okay, so the standard method that nominalists use to address this problem is what's under 2 on the first page of that. So the idea is one has a paraphrase strategy. So one is going to associate with every mathematical sentence a non-mathematical sentence. And the idea is that the non-mathematical sentence captures the grain of truth that mathematical sentences have, even though there are no numbers. So are people familiar with the notation, with logical notation under examples? I can explain it, but people should. Yeah. Otherwise, Francesca will give you a bad grade. Yes.
Or a quick introduction to predicate logic.
That's right. Okay, so here are some examples of paraphrase functions that one might give. So the first formula there is read, the number of the dinosaurs equals 0. So the octothorpe, this thing, that thing is read the number of, so that's just the number of f's, and that says that the number of f's equals 0. So one might ask, suppose you're a nominalist and you think that there are no numbers, so maybe this can't be strictly true because the number 0 doesn't exist, but what is the grain of truth in that sentence? The idea is, well, maybe this is a grain of truth, that there are no f's. And the nice thing about this sentence is that it is entirely non-mathematical. One might think that it uses vocabulary and pure logic. So that's something that even a nominalist could accept. And then the idea is we have perfection because we have a very clean picture of the world. We have a very clean metaphysics. And we can explain why mathematical sentences would be worth asserting. Okay, so let me pause briefly to make sure that nobody has questions so far. Nominalists have different stories about how it is that one can get from a mathematical sentence to its paraphrase. One common story is to say that when one asserts a mathematical sentence, one does so in a spirit of make-believe. So the idea is that saying the number of the f's is 0 is a little bit like saying I have butterflies in my stomach. Is there an equivalent Italian?
Farfalle nello stomaco.
Yes, exactly. So of course it's not really that you have butterflies. That's not what you're saying.
Hopefully.
Hopefully, yes, if all goes well. Really, you just use that figuratively to really say something else, which is that like you have a certain like bodily sensation associated with excitement or something like that. So in the mathematical case, you might say something similar. You might say that saying this is kind of like saying I have butterflies in my stomach. It's just a figurative way of saying that. And then you would think that we have answers to all problems because you can explain how it is that we're able to communicate using mathematical sentences in spite of the fact that there are no numbers. We just say things figuratively, and what we figuratively say is not number involving at all. So that's the thing. Unfortunately, there are problems in paradise. So the main thing I want to tell you guys about today is a formal result, proof, that shows that there is a certain sense in which the dream that I just described is in fact impossible. So one cannot do for fundamental reasons what nominalists wanted to do. So I'm the bearer of bad news. Okay, so before I can say exactly what the bad news is, so I'm going to tell you about an impossibility theorem. Before I tell you about the impossibility theorem, we need to get a little bit clearer about the objective. So we need to get a little bit clearer about what exactly the dream would consist of. So what the nominalist would need to do in order to really be able to develop the view that I was gesturing at here. So if you look at the bottom of page 1, under trivialist paraphrase functions, you will see the objective in a little further detail. Okay, so what the nominalist wants is paraphrase function. And the idea is this. So over here you have a bunch of mathematical sentences, things like the number of the f's is 0. And over here you have a bunch of non-mathematical sentences, things like there are no f's, but you have many others. And what we want to define is a function f, which takes each sentence over here to a sentence over there. And we want f to be recursive in the following sense. We want it to be the case that it's possible to program a computer so that if you give the computer a sentence on this side, it is able to calculate a sentence on that side. So if maybe God could come up with a different kind of function that's like so complicated that no computer would be able to capture it. But because we are finite beings, the only kind of paraphrase function we would be interested in is the kind that can be finitely specified. And the things that can be finitely specified are the things that one could in principle program a computer to do. Okay. But of course, not every mapping will do. So for example, it's not okay if we map this sentence onto the sentence that says Andrea has a mustache. We need some constraints about how the function is gonna work, and the constraints are on page 2 of your handout. So there are 3 constraints, A, B, and C, and what I'm going to do is I'm going to go through them. So the first constraint is what I call the counting constraint. And the idea is that whenever you have on this side something of the form, the number of the f's is n, that gets mapped onto something that says there are exactly n f's. Is this something that gets explained in Francesca's logic class?
Oh, this month.
Oh, okay.
Maybe a very quick explanation of that.
Okay. So, if anyone wants, I can explain it, but if you turn to page 1, you can see the formal definition on the margin. So the very first margin note is a formal definition of what that means, but I'm going to explain it right now. So, you should. It's typical that a philosopher would not be able to. Oh, yeah. There's 2 philosophers. So, what this means is there are exactly n things such that they are x. And we define that recursively. So if you say they're exactly one thing, what that means is that's just equivalent to there is something which is an f, and if you pick anything else and it's an f, then that thing is just x. In other words, there's exactly one f. And to define there are exactly two f's, what that means is there's an x and a y such that those things are f's. And if you find anything else that's an f, then either it's x or it's y, and so forth. So what's nice about this notation is that it's a purely logical way of saying there are exactly n f's. So what the counting constraint says is that mathematical sentences that say the number of the f's is n just get mapped onto these, they're exactly n f sentences. And really that's crucial. I mean, unless you have this, it would be hard to think of f as really a paraphrase, as really not just changing the subject. I mean, it should be, everyone should agree that what this sentence tells us about, as it were, the non-numerical world is that. Okay, so that's constraint number one. Constraint number two, which is B on page 2, is the inferential constraint. And what that means is that logical consequences here are preserved over here. So if you have two sentences in here such that this one entails that one, and that gets mapped onto something here, and this gets mapped onto something here, then that will entail that. So one way to say this is that the paraphrase takes logic seriously. It takes logical consequence seriously. Okay, and there is one final constraint, which is C on page 2, and that's the triviality constraint. And here's what that says. So notice how when we looked at the counting constraint, and we looked at what happens to a sentence like the number of the dinosaurs is 0, that got mapped down to there are no dinosaurs, which imposes a non-trivial demand on the world. So in order for this to be true, there is a certain way the world needs to be. It has to contain no dinosaurs. So to put it metaphorically, when God made the world, if God was to ensure that this turned out to be true, God needed to be careful. God couldn't just do anything at all. God needed to create the world in a certain kind of way. Had God created a dinosaur, or well, I guess dinosaur at this time, then that would have turned out to be false. So that's a sense in which this sentence gets mapped onto something that imposes a non-trivial demand on the world. What the triviality constraint says is that if instead of looking at sentences of applied mathematics like this one, you look at sentences of pure mathematics, like this one, then the thing they get mapped onto requires nothing of the world. So for example, it just might be a tautology. If you want to see an example of how that might work, you can go back to page 1 in the handout, and under 2 of the paraphrase strategy, you can see an example of what one might want to map 1 + 1 = 2 to. So it just gets mapped onto a sentence that says, if you have a thing and a thing different from that, then there are exactly 2 things, which are one or the other. So that's a paraphrase function, and it takes you from a mathematical sentence to a non-mathematical sentence. And the feature of the non-mathematical sentence is that it's just a tautology. It's something that's logically true. So when God made the world, there is nothing special that God had to do or refrained from doing in order to make that the case. Whatever God might have done, it would have turned out that that tautology, and indeed any tautology, is going to be true. And why is that? It's because the negation of a tautology is absurd, and even God cannot create the absurd. So even God cannot make it the case that it, for example, it's true that P and that not P. That's not amongst God's choices. When creating the world, God can only choose amongst coherent ways for the world to be. So the third constraint on this function is just that C on page 2. It's just that if what you have here is a mathematical, it's a truth of pure mathematics, it gets mapped onto something trivial. And if you have a falsehood of pure mathematics, it gets mapped onto something impossible. And there are many reasons for thinking that the triviality constraint ought to be in place, but let me give you just one. So suppose that you're a fictionalist of the kind I was talking about earlier. So suppose that you think that when one asserts a mathematical sentence, one is asserting it in a spirit of make-believe. It's like saying, there are butterflies in my stomach. What does a fictionalist think one learns about the actual world when one figuratively asserts a mathematical sentence? Well, the idea is that one learns that the actual world, I'll draw a picture. So say that this is the actual world. It's the world as it actually is. And over here we have the fictional world. And the idea is that it has a concrete part, which is just like the actual world. But it has something extra. In our fictional worlds, we also have numbers. So let's say that I fictionally assert the number of the dinosaurs equals 0. Then the idea is that, or well, let me make it 7. Then the idea is that what you've done is you've described the fictional world. You've said that the number 7, which lives here, numbers the dinosaurs. So what do you learn about the actual world? Well, what we're presupposing, the game we're playing, is that although the fictional world is different in its mathematical part, that the non-mathematical part is just the same. So what you learn is that there are 1, 2, 3, 4, 5, 6, 7 dinosaurs in the actual world. So generally speaking, when you make a fictional assertion, what you learn about the actual world is the non-mathematical part of that assertion. But now what happens when instead of asserting a sentence of applied mathematics, you assert a sentence of pure mathematics? Then all that does in the fictional world is tell you about this side of things. This has no consequences whatsoever about the non-mathematical part of the fictional world. So what you learn about the actual world is nothing. So nominalists who are also fictionalists spell the view in a way that presupposes the triviality constraint. Yeah, first question, please.
Yeah, but why the numbers are separated? Like the dimension of the numbers is separated from the fictional world. I mean, why is just an extra dimension?
I mean, I drew it that way to emphasize that it's something you added on. But in fact, the fictionalist could develop the story in many different ways. So, one thing the fictionalist could say is that, yes, as you say, the numbers live in a different dimension. Maybe they could use Frege's terminology and say that it's a distinct realm where they live. Maybe what they could say is that numbers are not in space and time, so that really this was kind of misleading the way I drew it, because the way I drew it, it seemed like they're to the right of everything else. But they would say, no, numbers they're nowhere in particular. So that would make it more difficult to draw. So the idea is ask the fictionalist how they're thinking about numbers in the fiction. And those are the constraints you're operating under. That's the game you're playing. An interesting observation, though, is that for many purposes, the details of how the fictionalists think of numbers are not going to matter. Because regardless of how you draw the numbers and how you think they work, what fictional assertions tell you about the actual world is going to turn out to be exactly the same. Okay, so let me recap. Let me tell you what we have on the table so far. So I've been talking about the Nominalist Dream. So this picture of the world where there are no numbers, but it's nonetheless possible to talk mathematical talk, because whenever we make a mathematical assertion, really what we learn about the world is just its paraphrase. Really what we learn about the world is just non-mathematical sentence, which is in some sense the grain of truth behind the original mathematical sentence. And we have now specified more precisely what the paraphrase function has to look like. So I say that if a nominalist is really to spell out the dream. This paraphrase function has to satisfy the 3 constraints on page 2, A, B, and C. So what I'm going to go on to show is that under certain assumptions, which I think are very, very reasonable, it is impossible to specify a function that satisfies all 3 of the constraints. That is, it is impossible to define a paraphrase function that satisfies the counting constraint, the inferential constraint, and the triviality constraint. Yes?
I understand what's the difference between justifying the existence of numbers, we need the formula, and justify the existence of individuals, we need the second one. I mean, why is the problem the existence of numbers, and it's not the existence of individuals?
Of individuals like, rocks and volcanoes and things like that.
Yes, but there we have symbols. I mean, it's like a symbol in our formula, but it doesn't coincide with people or things in our world.
Oh, I like that question. So let me rephrase it and see if you like the rephrasing of it. You say, wait, it sounded like nominalists were against abstract objects, but in developing the view, it turns out that they use formulas. And one might think that formulas are abstract objects. Of course, the blobs of ink on the board, those are concrete things. But the blobs of ink are not the formulas themselves. They're just representations of the formulas. They're tokens of the formula type. And the types are abstract, so shouldn't the nominalist be concerned about that? Do you like that formulation of your question?
Right.
Well, let me tell you what I think the nominalist might say about that, and then I'll give you a chance to go again. So here is one way for the nominalist to be maximally concessive, for the nominalist to not even question the point, to say, I agree with what you said. What the nominalist could say is that she's just playing along. So she's doing all this just so that we, the non-nominalists, understand what she's trying to do. So, she goes on using mathematics, and we say, I don't understand what you're doing. And she says, well, let me explain to you in your terms, using machinery that you are comfortable with, what I'm doing. And then, of course, they in practice wouldn't go on to spell out paraphrase functions and things like that. They would just make assertions and learn things from the assertions. The mathematical vocabulary is just a crutch for our benefit. So that's one kind of thing that the nominalist could say. But do you want to say more? Okay, good. Good. This turns out to be a really important point, actually, and it's this sort of problem emerges in spades when it comes to the way forward that I suggest in part 2 of the paper. So, there are very delicate questions of that kind that my proposal faces. So I think that the issue you raise is a very important and non-trivial issue. Okay. Yes?
Just to see whether I got you right. So, shouldn't there be a problem? Is all this also supposed to work in the case of formal theories for arithmetic?
Yes.
So, shouldn't these guys have a problem with the usual stuff, like goodness and continuous? You try to map all your purely arithmetical sentences into first-order logic, right? And you say, oh, look at that, such a nice picture. I get rid of numbers, I get rid of all the stuff that concern numbers, and I get just a first-order translation, even though it's not plain first-order logic, but with numerical quantifiers. But that is supposed to be complete. But then again, Gödel kicks in and says, okay guys, you've been a little too sloppy here because you know that arithmetic is incomplete. So there is something, which is, by the way, which is a tautology, because there is a sentence in arithmetic which is true in every possible model of first-order arithmetic, but it's not derivable in it.
I like that.
But so your possible paraphrase is a non-starter anyway, because you would not be able to get all the sentences of arithmetic as tautologies of first-order logic.
I like that. I can tell that we have a logician in the room. So I think that point is exactly right. But I intend to be extraordinarily generous towards the nominalist. So instead of limiting attention to first-order logic, I'm going to let the nominalist have second-order logic, or third-order logic, or indeed nth-order logic for any finite n. And what we're going to see is that even under those generous assumptions, it can't be. Now, apologies to people who have no idea what second-order logic is. I'm going to say something very, very brief, just so it doesn't seem totally mysterious. It's going to be brief and also sloppy. Okay, so start with a sentence like, Susan runs. So Francesca has taught all of you how to formalize that in a first-order language. So you might rewrite that as Susan runs, where that's first-level predicate, and that's a singular pronoun. In a first-order language, you're allowed to do this really cool thing. You're allowed to take S and erase it and plug in a variable. So that might be read as saying something like, it runs. And you might say, it, who's it? And you say, well, it's not specified, it's just a variable. And you can bind the variable with a quantifier. You can say something like that, which might be paraphrased as something is such that it runs. Now, in a second-order language, you're allowed to do something even cooler than that. So instead of erasing the S and putting a variable there, you're allowed to erase the runs and put a variable there. So you can write something like that. Now, what does that mean? Well, it means something like Susan is like so. And again, you ask, what do you mean like so? Like what? And you say, well, I can't tell you, it's just a variable. But, as in the first order case, you can bind the variable with a quantifier. So you can say that. And then you read that as something like things be somehow such that Susan is like so. So it's not like there's a way for things to be such that that's what Susan is like. And this makes our languages be extraordinarily powerful. So mere first-order languages seem like a toy in comparison with the power of these languages. And that's just second-order languages. So logicians have devised third-order languages and fourth and fifth and sixth, all the way up. So when I said to Francesca that I was going to be generous towards the nominalist, what I meant was that I'm going to allow her to use nth-order logic for any n. So really powerful logical resources. By the way, merely saying that this is logic is already controversial. So I'm granting the nominalist something that some people would say is like not even allowed, it's not even logic. Quine, for example, described this kind of thing as
Set theory in this case?
exactly
Oh, a set theory in sheep's clothing.
sheep's clothing. It's just set theory in this case. Anything else before we move on? Okay.
Yeah, I have just a very nice.
Yes, please.
I was just wondering whether one could avoid finding out function which sentences, troublesome sentences on the other side, to avoid this trick by saying that we can just mark, in a sense, the serious uses of the sentences from the non-serious one, and just say, when you are talking about what seems to be real language, actually this has to be understood as a mere façon de parler. And in this way, one could maybe avoid trying to account for your pre-constraints. I don't know whether this is a trick that some philosophers...
One of his colleagues.
Yeah, no, indeed. I think that is...
I'm afraid I'm not a philosopher of mathematics, so maybe I just said that something is...
Oh no, you said something which is exactly the kind of view people like. So I think, you know, as Andrea said, indeed one of my colleagues has forcefully argued that when one uses mathematical vocabulary, that really just is a façon de parler. Now, there are two ways of making that move. There's the sloppy way, where you say it's a façon de parler, and then say nothing else. And then the rigorous way of doing it, where you say it's a façon de parler, and now I'm going to explain to you just what it is that the real content of what you said is. So it's like in the butterflies in your stomach case, it's kind of like the person who says, oh yeah, it's just a façon de parler. And someone who says, it's a façon de parler, but what I really mean is that like you have a certain kind of sensation in your stomach, and yeah, that's correlated with blah, 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 blah. So what I'm trying to say here is that once you get rigorous, then you realize that it can't really be done. And that the dream has only remained in place because people have not tried to do it rigorously. In fact, like, I say this as if I was excited by it, but in fact, I'm saddened because like this is the story of my own failures. So like my dream when I was writing my PhD thesis was that I was going to do it. I was going to use some of these super powerful logics to show that once your logic was powerful enough, that you could be rigorous. And the result I'm about to tell you about was like the catastrophic failure of my PhD thesis. All right. Anything else before we move on? Okay. So towards the bottom of page 2, I have stated the bad news. So it is impossible to specify a trivialist paraphrase function for the language of arithmetic. So that's a little bit sloppily put, but I will explain. So really what I mean is that there's no uncontroversial way of specifying a trivialist paraphrase function. If your philosophical views are crazy enough, then you might think that there's a way of doing it. But what the theorem shows is that there's no way of doing it which is neutral enough that even people with non-crazy views are going to be in a position to adopt it. So this is what I mean when I say non-uncontroversial. And now I'm reading from the bottom of page 2. So first, that you not make controversial linguistic assumptions. And here I'm being super generous. So I'm letting people use first-order languages or second-order languages or third-order languages and so forth. But at some point I draw the line. So I'm not allowing people to use infinite-level languages. I think that to say that that's controversial is a huge understatement. So like already this is somewhat controversial, to say nothing of like seventh-order language. So I just draw the line at the finite. So that's the first restriction. The second restriction is that one not make controversial metaphysical assumptions. And the crucial assumption I have in mind here is that whatever paraphrase functions the nominalists use allow for the possibility of a finite domain. So remember how this works. So we have our mathematical sentences and our non-mathematical sentences, and we're mapping from one to the other. And because we're mapping true things over here to trivial things over there,